A. On the grid, draw the image of 1. Triangle A after a translation by the vector -3, 2. The number on top represents how much you need to move it in the x direction or parallel to the x direction. And the number at the bottom represents how much you need to move it in the y direction. So that's up and down, parallel to the y-axis. So we need to go -3 in the x direction. -3 refers to the left-hand side because as you go to the left, it's decreasing x. So we're going to go to the left by 3 spaces. And then we need to go in the y direction by 2 spaces. It's +2, so we need to go upwards because upwards is increasing y. So we need to go upwards by 2 spaces. And then we just need to move the triangle there. So the triangle is just going to be plopped right there. It's not going to be flipped. It's not going to be enlarged. It just needs to be moved to that position. Okay, then 2. Triangle A after a reflection in the line y equals x. So first, draw the line y equals x, which is diagonal across the middle of the axis. When you reflect shapes in diagonal lines, it's slightly difficult, but then the concept is still the same. The perpendicular distance from the original shape to the line and the distance from the line to the new shape or the reflected shape is still the same. In terms of counting the blocks, if we take this point on the triangle, it is 1 space to the right from the line, so we go 1 space down, which is in a different direction, 1 space down across from the line, so the new point is there. And for this point, it's 5 spaces across to get to the line, so we go 5 spaces down to get to its new position. And then for the last one, we could go 4 spaces down and then 4 spaces across to get to the new position. And there is our new position, or the new reflected triangle. If you don't like this method though, you can always use a ruler to help you, especially those ones with it's a triangle with a right angle there, because the perpendicular distance has to be the same from the line to the original shape and to the reflected shape. You can use the right angle to measure the distance, the perpendicular distance from the line to each point, and then flip it the other side to find out where that is for the reflected shape as well. Or you can use a transparent ruler and then align it across the straight line or the line of reflection. Align it so that one of the lines that measures stuff on the ruler is on top of the line, and then do the same thing. So we need to make sure that the perpendicular distance from corresponding points on the two triangles are the same. And we can do this for the other one as well. So make sure that these 2 points are the same distance from the line of reflection. B. Describe fully the single transformation that maps triangle A onto triangle B. So for these describe the transformation questions, you can look at the number of marks as a clue as to what the transformation is. If it's 3 marks, it's enlargement or rotation. And if it's 2 marks, it's reflection or translation, because when you describe a reflection or a translation, you give less information. So they will give you more marks for giving more information. So for this one, from A to B, you can see that it's been flipped, like that. So it's probably rotation, or actually definitely rotation. And if you try and imagine the triangle and you rotate it like this, anti-clockwise, 90 degrees, like that, it fits triangle B. Therefore, it's definitely rotation anti-clockwise by 90 degrees. And then the last piece of information we need is from what center. So to find the center of rotation, you can use a ruler to help you. The center of rotation is equal distance from the corresponding points from the two triangles. And if you draw a line from the corresponding points to the center, it should also make a right angle as well. So we can use the corner of the ruler to aim and find a point where it's the same distance from these two corresponding points. And it should be around there. Okay, and as you can see, it makes a right angle because the ruler is a right angle. And if I draw lines from that point to the corresponding points, the distance between those two lines and the point is also the same. As in, the distance from the point to the center of rotation is the same for both points. So that is the center of rotation. And this applies to the other points on the triangle as well. So if you try it for this point and draw the lines from that point to the center and from its corresponding point to the center, you can see that again, it makes a right angle with each other and it's also the same distance. And we can also do this for the last one. And again, it also makes a right angle and the distance is the same. So that's definitely the center of rotation. So the center of rotation is right there. And the center of rotation is 1 minus 1.